All right, get ready because today we're going deep into GCSE chemistry, specifically ionic bonding.
It's a good one.
Yeah, so if you're like studying for your GCSEs or you just want a refresher on ionic bonding, this is going to be the deep dive for you.
Definitely.
I've got all my notes and study guides here.
Awesome.
And I've got, of course, a chemistry whiz with me to help break it all down.
Happy to be here.
Okay, so let's just start with the basics.
Sure.
What are ions? I mean, I always imagine them as like these tiny little charged particles.
Right.
But how do they actually form?
So imagine atoms are like these tiny little things that really want to be stable.
Okay.
They want a full outer shell of electrons.
Like a perfect little friend group.
Exactly. Yeah. Not too many, not too few.
Okay.
And that's where ions come in.
Oh, yeah.
When an atom gains electrons, it becomes negatively charged.
Okay.
And we call that an anion.
An anion.
But when it loses electrons, it becomes positively charged.
Right.
And that's a cation.
So it's all about like electrons moving around.
Yeah.
Is there a way to like remember which one is which?
Yeah, so there's a good mnemonic for cations.
Okay.
You can think K plus ion.
Okay.
And the car reminds you of cat.
Uh-huh.
And cats are always positive.
Oh, I like
most of the time. At least
they're positive little creatures.
Yeah.
Okay, cations, positive pals.
Yeah.
What about anions? Any good mnemonics for those?
You can link negative anon.
Okay, yeah.
To remember those?
Cool. So we've got our positive cations and negative anions.
Yes.
Can you give us a real world example of like how this plays out?
So think about sodium chloride.
Okay.
Which is table salt.
Okay.
Sodium is a metal, and it really wants to lose its outer electron. Chlorine, which is a nonmetal, really wants to gain one to get a full outer shell.
Okay.
So sodium's like, here's my electron, throws it over to chlorine, and then you have a positively charged sodium ion.
Okay.
And a negatively charged chloride ion. Chloride.
So it's like a little electron giving and taking love story.
Exactly, yeah.
And so then that attraction between them is what keeps them together.
Exactly.
That's the ionic bond.
Yeah, it's called electrostatic attraction. It's a strong force, and that's what forms the ionic bond.
Awesome. Okay, so that's starting to make sense.
Good.
So how do we figure out what charge an ion will have?
Okay, so
I remember the periodic table being really helpful here.
Yes, it's like our cheat sheet.
Okay.
So elements in the same group, which is the columns on the periodic table, they tend to have similar behavior when it comes to gaining or losing electrons.
So if we know where an element is on the periodic table, we can figure out what its charge is going to be.
Most of the time, yeah. Okay. So for example, all those group 1 elements.
Like sodium and potassium?
Yeah. They want to lose that one outer electron to become a +1 ion.
Okay.
And group 7 elements like fluorine and chlorine.
Okay.
They want to gain an electron to become a -1 ion.
So there's definitely a pattern here.
Yeah.
Is it always that straightforward, though?
It is most of the time, but there are some exceptions. Some element, especially those transition metals.
The ones in the middle?
Yeah, in the middle of the periodic table. They can have multiple ionic charges.
Okay.
So you'll just have to memorize those.
So we've got our ions. We can kind of predict their charges.
Yes.
But how do we actually show this whole bonding process happening?
So for that, we use dot and cross diagrams.
Ah, those bring back some memories.
They're very useful.
Can we walk through an example?
Yeah, so let's take sodium chloride again.
Okay.
Sodium has one outer electron, so we represent that with a dot.
Okay.
And then chlorine has 7, so we'll represent that with crosses. And then we draw an arrow to show the electron moving from sodium to chlorine.
Okay.
And now they both have full outer shells.
So sodium becomes Na+?
Yes.
Because it lost an electron, and chlorine becomes
right.
Because it gained one.
Exactly.
And we show that with those brackets and the charges on the outside.
Yes, exactly. That's so cool.
It's a good way to visualize it.
Yeah, so we can use the periodic table to figure out the charges.
Yeah.
And then we can use these diagrams to actually see it happening.
Yeah.
I like it.
And remember, these diagrams are just a simple way to show it.
Right.
In reality, they form giant structures.
Wow.
Called lattices.
Lattices.
And it's a repeating pattern of the positive and negative ions.
So like building a big Lego castle out of ions.
Exactly.
That's awesome.
Yeah.
Okay, so before we get into the properties of ionic compounds.
Sure.
I think it would be helpful to see one more dot and cross diagram.
Okay.
Could we do one that's maybe a little bit more electronically complex?
Yeah, let's try magnesium oxide.
So magnesium is in group 2.
Okay.
So it has 2 outer electrons to give away.
Right.
Oxygen is in group 6, so it needs 2 electrons.
It's a perfect match.
Yeah.
So magnesium gives away those 2 electrons.
Uh-huh.
And now they both have a full set of 8.
Exactly. And that means magnesium becomes Mg2 plus and oxygen becomes O2.
Perfect. Okay, I think those diagrams are really helpful to visualize what's going on.
Yeah.
But what about the bigger picture? Like, what makes ionic compounds special?
So their special properties come from that electrostatic attraction between the ions.
Okay.
And those properties are actually what make them so useful.
Okay, I'm ready to hear about these superpowers.
All right.
Let's do it.
So first, let's talk about melting points.
Okay.
Ionic compounds have really high melting points.
Okay.
Because those electrostatic forces are holding the ions together so tightly.
So it's like trying to pull apart two really strong magnets.
Yeah.
You need a lot of heat to break those bonds.
Exactly. To melt something, you
Right.
need to give those particles enough energy to overcome the forces holding them together.
Right.
And in ionic compounds, those forces are really strong.
Okay.
Which means they can withstand really high temperatures.
Makes sense, like salt is solid at room temperature.
Right.
What about electricity, though?
Okay.
I remember ionic compounds conduct electricity,
Yes.
but only under certain conditions.
Yeah, this is where it gets interesting. So
Okay.
in a solid state, the ions are all locked in that lattice structure.
Right, like they can't move.
Exactly. So they can't carry an electrical current.
It's like a traffic jam.
Yes.
They're stuck.
But if you melt an ionic compound
Okay.
or dissolve it in water,
Uh-huh.
then those ions are free to move around.
And then they can conduct electricity.
Exactly.
The traffic jam is cleared,
Yes.
so they can carry that electrical charge.
Yeah, so they conduct electricity when they're molten or in solution.
But not when they're solid.
Right.
That's so cool. It's like a little switch.
It is.
What kind of real-world applications does that have?
So think about electrolysis,
Okay.
which uses electricity to drive chemical reactions.
Hmm.
It's used for extracting metals from their ores,
Oh, wow.
like aluminum in fence,
Okay.
and also for things like producing chlorine gas,
Interesting.
which is used for purifying water.
So these tiny little compounds are doing big things.
They are.
What else?
Well, we already talked about salt,
Hmm.
but think about ceramics.
Okay.
They're known for being really hard
Uh-huh.
and having high melting points because
Yeah.
they're made up of ionic compounds.
So like the tiles on my bathroom floor,
Yeah,
they're held together by these strong ionic bonds.
exactly. And they can withstand high temperatures.
That makes sense.
So they're perfect for things like ovens
Oh, right.
and heat-resistant cookware.
Wow, we're surrounded by ionic compounds.
We are.
It's amazing.
It is. That's what makes chemistry so fascinating.
Okay, I think we've learned a lot today. We've
Yeah.
talked about what ions are, how to predict their charges,
How to draw them.
their properties,
Yes.
and even real-world applications.
It's been a good journey.
It has. Before we wrap up,
Sure.
do you have any final thoughts or challenges for our listeners?
So we've talked about how the properties of ionic compounds
Yeah.
make them useful,
Right.
but how do those properties also relate to potential hazards?
Ooh, okay.
So think about this. What happens if you drop an electrical appliance into a bathtub full of water?
That's a good question.
What do you think happens?
I have a feeling it has something to do with those free-moving ions.
It does. Remember, water can dissolve ionic compounds.
Right.
And those dissolved ions can conduct electricity.
Okay.
So if you drop an electrical appliance into the water,
Uh-huh.
it creates a path for the electricity to flow.
And that could be dangerous.
Yeah, it can lead to an electric shock.
So understanding this stuff isn't just about passing exams.
No.
It's about being safe.
Exactly.
Wow, that's a good point.
Yeah, chemistry is everywhere.
Uh-huh.
And the more we understand it,
Right.
the better we can navigate the world.
I love that. Okay, well, I think we've given our listeners
Yeah,
a really good overview of ionic bonding today.
I hope so.
So thank you so much for explaining all of this.
It's been a pleasure.
It's been so fascinating. So as to our
Yes.
listeners, keep exploring, keep asking questions,
Yes.
and keep that chemistry spark alive.
Definitely.
You'll be back soon with another deep dive.
Awesome.
So stay tuned. Until next time. All right.